This is number 38 from Chapter 7, the end of chapter problems. It reads, an FM radio station broadcasts at 99.5 megahertz. Calculate the wavelength of the corresponding radio waves. Now, this is a fairly simple calculation as long as we recognize what equation we need to be using. We are given a frequency, and we want to calculate a wavelength. And so we can use lambda equal to c over nu. Again, this has already been rearranged a tad bit from the original c equals lambda nu. All I did here, divide both sides by nu so that I could get lambda by itself because I'm trying to solve for wavelength. So I have wavelength is equal to the speed of light divided by the frequency. And I have frequency, but I'm going to want to make a small change to the way it's listed here, and hopefully you'll see why in a moment. So 99.5 megahertz is the same thing as 99.5 times 10 to the 6th hertz. All right, that's what the prefix mega means. Now, what I'm going to do with this hertz is I'm going to sub this out for one of its synonyms, one of the things that means the exact same thing. There's 1 over seconds, means the same thing, or seconds to the -1, because when you raise something to the -1 or to any negative exponent, it flips that value so that value is now on the denominator of a fraction, like we see here. And the reason I'm going to do that is when I plug in these values, the speed of light and then the frequency, it's going to make it a little bit more simple. So I'll use 2.998 times 10 to the 8th meters per second. That's the speed of light. And then 99.5 times 10 seconds to the -1. Now we can see here, excuse me, what we should be able to see here is that the seconds here and the seconds here will cancel. And so the only unit I will have left is meters right here. Now, getting out your calculator, doing some simple calculation, and again, I would strongly suggest that the first calculation you do does not involve the exponents at all. In your calculator, I strongly suggest doing 2.998, then dividing that by 99.5. I suggest getting an answer for that, and then dealing with your exponents secondly. All right, let's get out my calculator here so I can actually do that. Technical difficulties. All right. Calculator's not working as well as I had hoped. No, don't really want to do that right now. Okay, here we go. Let me get some action here. Let's see, can you even see that on the... Okay, anywho. So go 2.998 divided by 99.5. That's going to give me... The calculator is going to tell me that is... Actually, I'm sorry. I'll put that down here. 0.03013. Now, I have 3 significant figures here, so I'm going to round that to right there. So I'll actually have 0.0301. Now let's deal with this exponent right here. I have a times 10 to the 8th divided by a times 10, oh, that should be a times 10 to the 6th. Divided by a times 10 to the 6th. That's going to leave times 10 to the second. Remember your dividing exponents rules, you simply subtract them. You find the difference. And the difference is 2. This isn't quite scientific notation. Include the unit, don't forget the unit. I just multiply this by 10 to the second, 1, 2. So I can actually have a very simple answer, 3.01 meters. The wavelength of this exact frequency is going to be 3.01 meters.